example number 2. Let's do example number 2. So for P, God bless you. For P, it says that the ray is an angle. A ray is a angle bisector. Okay. So then the conclusion. Sorry, not hypothesis. Mr. Adams is having a rough day. I gotta let the coffee kick in. So then the Q statement would be a ray divides an angle. Bless you. Into two congruent. Please don't do that while I'm recording. Two congruent angles. So now what we need to figure out, what the textbook wants us to do, is we're gonna do a little practice, okay? Let's do the conditional statement. So if I do the conditional statement, what implies what? Can somebody tell me? Go ahead.
Implies Q.
P implies Q. So how do I write that? Go ahead.
If a ray is an angle bisector, then it divides an angle into two congruent angles.
Right. So it says if a ray is an angle bisector, then it divides the angle into two congruent angles. Well, we talked about that in one of the previous sections, so we know that's true, right? So the next thing is we want to see if we can write a biconditional statement. So before I even bother writing the biconditional statement, I need to verify if it is in fact biconditional. So now, how do we verify if something was biconditional or not? Yes?
You do the converse.
We got to do the converse. So the next thing in this process is that we're going to do is we're going to write the converse. So the converse is we're just flip-flopping Q and P. So now Q is going to imply P. Okay. So how do I write that?
If a ray divides an angle into two congruent angles, the ray, then the angle, or then the ray.
Absolutely correct. She said if a ray divides an angle into two congruent angles, then it is a angle bisector. Right? Now, is that true? Yeah, that's true. Now, you might say, Mr. Adams, why are we using these examples for proofs when you already told us that's true and all that stuff? Well, we got to start with something that we know to verify, right? If I threw some statements out there that were a little ambiguous and kind of hard for us to determine whether it's true or not, we wouldn't really understand the concept of a biconditional statement. What do we got to do to make sure something's biconditional? Well, we need to establish that the conditional statement is true and that the converse is true. And we know, because we practiced some of these problems, that both are true. So if they are both true, then we can write a biconditional statement. And the biconditional statement would be P can imply Q, but it can also imply P, or Q can imply P, right? That's what biconditional means. It means that one can imply one and the other can imply the other. Does that make sense?
Two conditions.
Two conditions, and they both imply each other, right? So now, how do I write that?
If and only
If and only if a ray divides. Well, let's stick to P and Q. What was P? I forgot now.
Array with an angle.
Oh, if it's an angle by, yeah. If and only if a ray is a angle bisector, then it divides the angle into two congruent angles. Does that make sense? Okay. Any questions on that?